Have you ever wondered how crucial systems like spacecraft or aircraft manage to keep running even when components fail? Ensuring continuous operation is a major challenge in system design, especially in distributed environments where many parts work together. There are several powerful strategies to keep these systems robust. N-Modular Redundancy, often shortened to NMR, is a powerful technique for fault tolerance. However, to directly answer the question, NMR is generally not suitable for all distributed systems. While it offers exceptional reliability, its significant overhead and specific fault model make it a specialized solution rather than a universal one. At its core, NMR involves running multiple identical copies, or modules, of a system in parallel. These modules will perform the same computations simultaneously. A voting mechanism then compares their outputs and selects the majority result as the correct one. For instance, in a triple modular redundancy system, if one of three identical modules produces an incorrect output due to a transient error, the other two modules will outvote it, masking the fault. This approach is highly effective for dealing with random hardware failures and transient faults, ensuring that the overall system continues to function correctly even when individual components experience issues. Its primary strength lies in providing immediate fault masking without requiring system restart or failover. So, when should you consider NMR for your distributed system? You should primarily consider NMR if your system operates in an extremely safety-critical environment where any failure could lead to catastrophic consequences, such as loss of life or mission failure. Think of aerospace systems, certain medical devices, or industrial control systems for dangerous processes. It is also a strong contender when deterministic behavior is paramount and you need to mask transient hardware faults immediately. However, if your system can tolerate occasional downtime, prefers eventual consistency, or if resource efficiency is a major concern, simpler and less costly redundancy schemes like active-passive or active-active replication might be more appropriate. It is also important to understand that NMR primarily addresses hardware and transient operational faults. It does not inherently solve issues arising from software bugs, as those bugs would be replicated across all N modules. This limitation highlights a key distinction. NMR is a specific tool in the broader toolkit of fault tolerance, which also includes concepts like Byzantine fault tolerance, or BFT, that can handle malicious or arbitrary failures. Many common distributed systems, such as web services, achieve high availability through software-level replication, graceful degradation, and robust retry mechanisms, often at a much lower cost and complexity than NMR. In conclusion, while N-Modular Redundancy provides an exceptional level of fault masking and is indispensable for the most critical applications, its substantial demands on resources and its particular focus on certain types of faults mean it is far from a one-size-fits-all solution. For the majority of distributed systems, selecting a fault-tolerant strategy that aligns with their specific risk profile, cost constraints, and performance requirements is a more practical and effective approach than implementing NMR across the board.
If this helps you code smarter, like, subscribe, and stay tuned for more.